In this lesson, we're going to be identifying and writing equations of parallel lines. We're going to be identifying and writing equations of perpendicular lines, and using parallel and perpendicular lines in real-life problems. Parallel lines and slopes. Two lines in the same plane that never intersect are parallel lines. Two distinct non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel. Okay, so basically, if you know that two lines have the same slope and they are different lines, then they are parallel. Determine which of the lines are parallel. Well, I can see that all three of these lines are different lines, and if you remember, parallel lines have the same slope. So all I need to do is find the slope of the blue line, the red line, and the green line, and then I'll be able to determine whether or not they are parallel. So I'm going to start with the blue line, and I'll use my blue pen right here. So I'm going to start at this point, -3, 4, and then go to this point, 1, 2. So I'm going to go down 1, and I'm going to go right 1, 2, 3, 4, 5. So my change in y is going to equal -1 because I went down 1, and my change in x is going to equal 5 because I went right 5, so that's +5. And this is the same thing as -1/5. All right, now for the red line, line B, I'll start at this point and go here. So I'm going to go down 1, and then I'm going to go right 1, 2, 3, 4. Okay, so my change in y over change in x is going to be -1 because I went down 1, and then right 4 means +4. So my slope is -1/4. And last, I'm going to do the green line, line C. So I will start at this point. I'm going to go down 1, and then I'm going to go right 1, 2, 3, 4, 5. So once again, my change in y over change in x is going to be -1 over +5, which is the same as -1/5. So if I see here, I know that my blue line and my green line are going to be parallel because they have the same slope. The red line is not going to be parallel to the green line and the blue line because it does not have the same slope. Its slope is -1/4, whereas the green and the blue line's slope is -1/5. So I'm going to scroll down here and write that. Line A is parallel to line B. Two little lines next to each other indicates that the lines are parallel. And now we're done with this one. Write an equation of the line that passes through the point 5, -4 and is parallel to the line y equals 2x plus 3. So whenever I'm going to write an equation to the line, I want to start with a general form. So that's either going to be point-slope form or slope-intercept form. So I'm going to start with slope-intercept form. That's y equals mx plus b. And once I find my slope, which is m, and my y-intercept, which is b, I'll have the equation to the line. First, I'm going to start with the line that is given to me, y equals 2x plus 3. If you see here, I can identify the slope right away. Remember, the slope is the number that's being multiplied by x when y is alone and the equation is simplified. So y is alone here, the equation is simplified, and 2 is being multiplied by x, so my slope is 2. If you see here, this plus 3 is given to us, but that means nothing. We do not care about that. That is just the y-intercept of this equation. But we're going to have a new y-intercept. Our slope is parallel, but it's not the same line. Anyway, I can plug that in for m, and that's going to be 2 here. But I also have this point right here, 5, -4. So what I can do is I can plug these components in for x and y. Remember, my first value is x and my second value is y. And then I can simplify and solve that equation to find what my y-intercept b is, and then I will have the equation to my line. So let's do that right now. So my y value is -4. So -4 equals, I already have my slope from this line, which is 2, and then times my x value, which is 5, plus b. I will simplify. 2 times 5 is 10, plus b, and that's all equal to -4. And the last step would be to subtract 10 on both sides, and I'm going to get -14 equals b. Okay, so now I have my slope, and I have my y-intercept right here. So all I have to do is plug these two things back into my general formula for slope-intercept form. So I'm just going to rewrite this as y equals 2x minus 14. Okay, so that is how to find the equation of a parallel line to our given line y equals 2x plus 3 that goes through this point 5 comma negative 4. Okay, if you wanted to do point slope, what you would do is you would take the slope from here and the point from here and then set up your equation. I'll just start it, and if you really want to, you can do it on your own. So that would be y minus y1, which in this case, my y value is negative 4. So that's actually going to be y plus 4 equals my slope, m, which is 2, times x minus x1. Well, x1 is 5 here. And if you simplify this equation, it's going to be this. But since these instructions didn't specify which form you want it to be in, you can either be in slope-intercept form or in point-slope form. So now we've actually gone above and beyond and showed multiple ways how to solve this. Now we're done. So now we're going to talk about perpendicular lines. Two lines in the same plane that intersect to form right angles are perpendicular lines. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. And you'll actually hear me say opposite reciprocals. I think that's a better way to describe it rather than negative reciprocal. And then vertical lines are perpendicular to horizontal lines. Okay? So all this is saying is perpendicular lines create right angles when they intersect, and the slopes of perpendicular lines are opposite reciprocals. Determine which of the lines, if any, are parallel or perpendicular. So what you could do is you could graph all of these equations and then look at their slopes and then figure out whether or not they are parallel, perpendicular, or neither. Okay? But you don't need a graph to do this. We can just figure out what each line's slope is and then compare those to determine whether or not they're parallel, perpendicular, or neither. So I'm going to start with line A. If you see, line A is in slope-intercept form. This is y equals mx plus b. M, in this case, is 4. So my slope is 4 here. Line B is in standard form. It is not in slope-intercept form. So I'm going to convert it to slope-intercept form. So I'm going to subtract, I'll zoom in here actually first. So I'm going to subtract x on both sides. So I get 4y equals negative x plus 3. Okay. And remember, I always want my x term before my constant term. Now I'm going to divide the entire equation by 4. That's every single term. And I get y equals negative x over 4 plus 3/4. Okay. Now, if you're not entirely sure what the slope is going to be, you can always just put a 1 next to your x. And now this is the same thing as negative 1/4. Okay, so I could rewrite this as negative 1/4 x plus 3 over 4. And now I know my slope is going to be negative 1/4. Okay, so I'm going to zoom back out. And for line B, I'm going to write m equals negative 1 over 4. Right away, I can see that this slope for line B and the slope for line A are opposite reciprocals. The reciprocal of 4 is 1/4, and the opposite of 1/4 is negative 1/4. Okay, and if you do the same thing to negative 1/4, you'll get positive 4. Okay, so I can tell these are going to be perpendicular already, but let's look at line C. Line C is not in slope-intercept form, so I'm going to put it into slope-intercept form. First thing I'm going to do is add 2x on both sides. Zoom back in here. I get negative 8y equals 2x plus 16. Now I'm going to divide the entire equation by negative 8, each term. So y equals negative 1/4. X, 2 over negative 8 simplifies to negative 1/4. And then this is going to be minus 2. So once again, I see that this slope is going to be 4. Okay, so I know that line C is going to be parallel to line A, and lines A and C are both going to be perpendicular with line B, okay? Because the slopes here are opposite reciprocal, and then the slopes for line C and line A are the same. Therefore, they are parallel. So I'm just going to write that really quickly. A is parallel to C. A is perpendicular to B. This symbol indicates that these two lines are perpendicular. And last, I know that B is perpendicular to C. Okay? And now we're done with this one. write an equation of the line that passes through the point -3, 1 and is perpendicular to the line y equals 1/2 x plus 3. Well, this is similar to our write an equation of a parallel line, except for all we need to do is use the opposite reciprocal of the slope, because perpendicular lines have slopes that are opposite reciprocals of each other. Anyway, I'm going to do slope-intercept form again, but once again, you could always do point-slope form in this case. So I'm going to start with y equals mx plus b. That's my general formula for slope-intercept form. And now I'm going to look at the line that I'm given. That's y equals 1/2 x plus 3. Okay. Well, I can identify the slope of this line. I'll draw an arrow here. M of that line equals 1/2. But I want my new line to be perpendicular to this line. So that means I want their slopes to be opposite reciprocals, like I said earlier. So the opposite reciprocal of 1/2, well, the opposite of 1/2 is -1/2, and the reciprocal of -1/2 is -2. So this becomes -2, because that's my opposite reciprocal. So now I'm going to plug my new slope of the perpendicular line in, and I'm going to plug this ordered pair in, because remember, this is the x component, that's the y component, and we're going to be doing this to solve for b. And then once I have my b, I already have my m, therefore I can write an equation in slope-intercept form. So this becomes 1 equals my new slope, which is -2, times -3 plus b. Okay, well, -2 times -3 becomes +6 plus b equals 1. And all I have to do is subtract 6 on both sides. Scroll up here. And I get -5 is equal to my y-intercept. So now all I need to do is put this into an equation. My general formula, which is back up here, y equals mx plus b. My new slope, I should say, is -2. And my y-intercept is -5. So I'm just going to rewrite the equation y equals -2x minus 5. And this line right here, the equation of this line, is going to be perpendicular to the line from this equation. And now we're done with this one. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. All right, so there's multiple ways we can do this. Because the line is actually given to us, this red line right here, we could just write an equation given this point, but because this lesson is on perpendicular lines, we're actually going to find the slope of the shoreline and then use that and this point to find the equation of our perpendicular line. Okay, so I'm going to look for some points on this graph that I can find the slope from. So I'm going to zoom in here. If I'm looking on this graph, I see that this point, 4, 1, is on my shoreline. And I see that this point right here, 1, 3, is also on my shoreline. So I'm just going to write that in really quick. 4, 1, 1, 3. Now, all I need to do is rise over run to figure out my slope. Moving down 2, and then right 3. So I can instantly tell that my slope, change in y over change in x, is going to be -2 over +3. Okay. Now, I'm really looking for the equation of this line, the line of the helicopter, to get to the shore. Well, I already have the slope of the green line, and I know that these two lines are perpendicular from the question above, so I can just do the same thing that I did in the last example. Okay, so in order to find the slope of this line, I'm going to take the opposite reciprocal of -2 over 3. Well, the opposite of -2 over 3 is +2 over 3, and then the reciprocal of 2 over 3 is 3 over 2. So my new slope, m, is going to equal 3/2, or 3 over 2. And I have this point here. This is the point 14, 4. And since the last couple examples I've used slope-intercept form, I'm going to use point-slope form here. If you remember, point-slope form is y minus y1 equals m times quantity x minus x1. Okay? Well, the y and the x just stay. Okay? And my slope is going to be, we just figured out, it's going to be 3 over 2. And then my x1 and y1 values, well, my x1 is going to be 14 and my y1 is going to be 4. So I'm going to plug these in. And if I look back up at the question, it says write an equation. It does not specify which form. Typically, you're going to want to write it in slope-intercept form for multiple reasons, but I'm going to start with point-slope form, and then we will get to slope-intercept form afterwards. So back here, I'm going to zoom in. So I'm going to plug my values in. Y minus, well, y1 is 4, equals my new slope, 3 over 2, times x minus 14. Okay. Now, we could just leave it here, but let's put it into slope-intercept form for fun. What I'm going to do is distribute this 3 halves to both my terms in the parentheses. Okay, so I get y minus 4 equals 3 halves x minus, well, if you notice, the 2 and the 14 would cross cancel, and the negative 14 would become a negative 7. So 3 times negative 7 is negative 21. Okay, last step here I'm going to do is add 4 on both sides. And I get y equals 3 halves x minus 17. So this is the equation that the helicopter will be taking on this graph right here. Okay, and now we're done with this one.